Types of wave. Waves can be put into one of two categories depending on the relative direction of these two factors. Waves transfer energy but not matter. We see this with water waves, where a ball sitting on the top of the sea would bob up and down but not actually go anywhere. Also, waves are produced by vibrations or oscillations. Let us first look at this situation where the lines could represent the coils of a slinky spring. The spring is being moved back and forth like this at this end, so the coils will go back and forth like this, or here, like this. So this is the direction of vibration of the coils. Energy will be transferred from the side that is being moved to the other side, so energy transfer is in this direction. We see the vibration and the energy transfer are along the same direction. It is a longitudinal wave because the vibration is along the same direction as energy transfer. In some areas, the coils get moved closer together. They're compressed. These areas are known as compressions. In other areas, the coils are further apart. They're rare. These areas are called rarefactions. The wavelength of a longitudinal wave goes from the center of one compression to the center of the next compression, or it could also go from the center of a rarefaction to the center of the next rarefaction. Sound waves are examples of longitudinal waves. In a sound wave, the air particles or the water particles or solid particles that the sound is travelling through will vibrate back and forth in the same direction as the energy is being transferred. Here we have another situation where this again could represent a slinky spring, but now the spring is being moved in this plane and energy is being transferred in this direction. So now vibration is at 90 degrees or perpendicular to energy transfer. This is called a transverse wave, trans meaning across, as in transatlantic, because the vibration is across the direction of energy transfer, or vibration is perpendicular to energy transfer. To show wavelength on a transverse wave, we would go from the center of one peak to the center of the next peak, wavelength represented by the Greek letter lambda, as shown here. We could also show from the center of one trough to the center of the next trough, or even from this position to the same position on the next wave. Amplitude goes from the equilibrium position at the center to the position of maximum displacement, or amplitude could have been represented here. Electromagnetic waves are examples of transverse waves, where in an electromagnetic wave it is a changing electric and magnetic field. Electromagnetic waves need no medium to travel through. They can travel through a vacuum, as sunlight does in getting to Earth.